Alright, so we've looked at how we would find the inverse when you're looking at a graph or when you're looking at a table. But we also want to talk about how you find the inverse when you have an equation. Okay? And it starts off the same way that it starts when you're looking at a table or a graph. You're going to switch x and y. Okay? If you see f of x, know that that represents y. Okay? It's not two different variables. F of x represents y. So when we switch x and y, f of x is going to become x, and x will become y. So that in number 6, that's our first thing. F of x is going to be x, because we're changing it, and x becomes y. And see that f of x was understood to be y. So I switched x and y. The next step says that we solve for y. So that's not an equals, that's a minus. We try to get y by itself after you switch x and y. And so to get y by itself on this problem, I'm going to add 5 on both sides. And then I'm going to divide by 2. Now, I want to tell you there's a couple ways that you can write your answer. And there's a couple ways that you might see it on multiple choice. One way is x plus 5 over 2, exactly like that. Another way that it might be written is this 2 might be divided by both things, so it might be x over 2 plus 5 over 2. And that's your answer. That's the inverse. Okay? If I would graph 2x minus 5 is one thing in Desmos, and I would graph either of these choices, whichever one, those two would make two graphs that are inverses. So we're just trying to figure out what the equation actually is that would be the inverse. And I just wanted you to see this because sometimes it's written differently and sometimes it's written either way. So you might have to separate it and divide it. If that was a 6, go ahead and divide it and get 3. Okay? Okay, so let's look at the next one. The next one's a very similar kind of problem. Remember that f of x is really y. So our first step is to switch x and y. So y becomes x, and x becomes y. Going to get y by itself. So I'm going to move this 3/4 over here to the other side. I want to subtract 3/4. Now, I need to get y by itself. So you can think about dividing by 1/4 if you want to, but that's kind of a little bit harder to think about as far as getting the answer goes. What I would suggest when you have something like that is multiply by 4. When it's 1/4 or 1/2 or 1/3, just multiply by that denominator, and that will eliminate the denominator here. So I'm going to multiply both sides by 4, which will give me y equals. Your answer probably will not be written that way. Your answer probably will be distributed out. So you do 4 times x, and then 4 times 3/4. And if you put in that 4 times 3/4, you will get a -3. So you may have fractions in your answers, and you may not. Just depends on the problem. And again, if you would graph the original and graph what we get as our answer, those two graphs would be inverses, and they would flip along y equals x. Now, sometimes they aren't lines. These two right here would have been lines if you would have graphed them. Sometimes they have powers or roots. And so we need to talk about how that would change anything as far as finding the inverse goes. So on number 8, again, we still want to switch x and y. And we want to get y by itself. Okay? Eventually I'm going to subtract 2, but I can't subtract 2 till I do something with that 3. I need to get rid of that 3 first. Okay? Right now the 3 is a power. So the opposite of a power when you get rid of it is a root. If there's a root there, I want to raise it to a power. If there's a power, I want to do a root. So it's kind of opposites to get rid of it. So what I'm going to want to do here is I want to take the cube root on both sides. So here I would get cube root of x equals y plus 2 because the cube root and the cube cancel itself out. I still want to get y by itself, so I would want to subtract 2 now on both sides. And so we get cube root of x minus 2 equals y. Okay, number 9. Similar kind of problem, except we're starting with a root. So that means our answer is going to have a power. If the root's are 5, the power is going to be 5. Okay? We still want to switch x and y. Remember, f of x is like y, so I'm going to change it to x. I forgot to switch that one. That one's supposed to be a y. Sorry about that. So I want to get y by itself. Like the last problem, how we made the root on both sides, this time it has a root, so I want to do the opposite, which means I want to raise it to a power. So I'm going to raise this to the 5th on both sides. So that would be x to the 5th equals y plus 2. Good so far? Try to find y by itself, so subtract 2 on both sides. And there's our function. The order that you do it in is important. Because the root and the power had it on over the whole thing, I had to do the root first. On this problem, I'm not going to do the root or the power right away because that plus 3 is separate. So let's look at that. First of all, I know that f of x is y, so I'm going to switch that to x, switch the x to y, and I need to solve for y. What I meant on this problem is, you see how the cube root is not over the 3? I need to move the 3 first so that I could get the root by itself first, so the order matters. So I'm going to subtract 3 on both sides. And then I want to get rid of the cube root. Okay, I want to raise both sides to the 3rd. And that will give me x minus 3 to the 3rd. Because when you do a root and a power, it makes itself go away. Alright, f of x is like our y, so we change that to x. X is our y. So we don't do anything with the power first. We need to get rid of this 3. So I would subtract 3 first. Then I need to get rid of the power. And because the power is a 4, this is where I want to do a root on both sides. And it goes over the whole thing because you're doing it all at once. The root and the power go away. And then the last step is to get y by itself, so I'm going to have to add 1.